Welcome back, everybody. Mr. Young here, computer science and IT teacher at Webster Groves High School. Okay, so we left off in part 2, running out of time, talking about branches with GitHub. And what the heck does that mean as it pertains to game developers using Unity? Well, and for this part of our part series, we're going to take a look at the GitHub guides page, which really does a great job of visualizing what some of these terms and concepts mean. So the first one we'll talk about here is a branch. It says when you're working on a project, you're going to have a bunch of different features or ideas in progress at any given time, some of which are ready to go and others which are not. Branching exists to help you manage this workflow. When you create a branch in your project, you're creating an environment where you can try out new ideas. And I would add there, in isolation from the rest of the team, meaning you can try out new ideas that may or may not be successful without impacting all of your other teammates in a collaborative game development team. Changes you make on a branch don't affect the master branch, so you're free to experiment and commit changes, safe in the knowledge that your branch won't be merged until it's ready to be viewed by someone you're collaborating with. So if you look at this diagram up here, this main thick line along the top here, this is actually the project itself. While developing a game, you're going to have ideas. Some fail, some are great ideas, some fall somewhere in between, and you have to make modifications in order to make them be successful. So what we're doing here is we're saying we can actually deviate away from the group and test out new ideas. Now, I will tell you from reading a lot of documentation and speaking with a lot of folks that have used GitHub over the years in an enterprise environment, they have said never work from the master branch, to work within individual branches and then only push to the master branch when the team supervisor or the team collectively agree that the change made by an individual programmer or a small subset of programmers is what they want and they're satisfied with, and they want to merge that into the end product. So think of this top bar up here as being the end product you're trying to produce, and then multiple teammates or subsets of teammates are going to work on different ideas and only come back to the master branch with their finished work when the group or the supervisor or the collective agrees that that's what they all want. Okay, so that is a branch, it's the master branch, and then you can make any other branches you want. As far as branch names go, highly recommend that you name your branch whatever skill, whatever concept, whatever idea that you're working on. Instead of just saying Tom's branch or Amy's branch or, Olivia's branch, those branch names really don't say anything meaningful. Whereas if you were to say something like controller script branch or sprite work branch, or maybe it is going to be some kind of physics branch or scene management branch, those branches are much more descriptive and allows other teammates that are not in your subset team to kind of look in and see what you're doing and maybe suggest some issues, some ideas for your team, and they can follow along. Okay, moving on here, we have adding commits. So what are commits again? GitHub says once your branch has been created, it's time to start making changes. Whenever you add, edit, or delete a file, you're making a commit and adding them to your branch. The process of adding commits keeps track of your progress as you work on a feature branch. Commits also create a transparent history of your work that others can follow to understand what you've done and why. Each commit has an associated commit message, which is a description explaining why a particular change was made. Furthermore, each commit is considered a separate unit of change. This lets you roll back changes if a bug is found or if you decide to head in a different direction. So if I go over and look at my project here for a second, this is where the commit messages show up. You do not need to use complete sentences here. You do not need to feel the need to make them extra explanatory. I tell my students to use fragments. What was the purpose of committing these changes to your branch or eventually to the master? Is it because you just recently updated a specific part of code? Is it because you just added a new sprite manager? Is it because you added maybe a scene management aspect? Try to be descriptive in these areas when you name your commits so that your teammates that are following, looking on, or even are a part of your little subset team, they know that these files were committed because these changes were made. So it's not a paragraph, it's maybe not even a complete sentence, but it should be just descriptive enough so that other programmers on your team collaboratively understand why changes were made to these files. Okay, we jump back over. That's adding commits. Then we have a pull request. Now you notice this is not saying pull, this is pull request, slightly different. Pull request initiate discussion about your commits. Because they're tightly integrated with the underlying Git repository, anyone can see exactly what changes would be merged if they accept your request. You can open a pull request at any point during the development process. When you have little or no code but want to share some screenshots or ideas, when you're stuck and need help or advice, or when you're ready for someone to review your work. By using GitHub's @mention system in your pull request message, you can ask for feedback from specific people or teams, whether they're down the hall or 10 time zones away. That system, for those of you that are Twitter users, it's the same concept. You put and the name of the teammate's GitHub username, and that message will show up on their GitHub page. If we bounce back over to GitHub, you see there is a page that says, or a tab that says issues. And this is where issues can be mentioned. We can go in here and say, I want to make a new issue, whatever the issue it is that you have, or maybe you need help with. And then over here on the right is where you can assign it to someone. So you can make it to where this gets delivered to another person's page. You can add labels like what you think the problem is. There's a spot here where it says projects, and we'll talk about that in a minute, but that's where you can designate this issue for a specific aspect of the game that a team is working on within the broader team. And then you can also set a milestone here, whether this is something big that has happened, something new that is happening, and so on. Okay, so this is under issues, and we'll get to projects here in just a moment. As we move forward, we have reviewing your code. Really important, right? Once a pull request has been opened, the person or team reviewing your changes may have questions or comments. Perhaps the coding style doesn't match project guidelines. Maybe you did something that your supervisor did not want or specifically said we're not doing. The change is missing maybe unit test, or maybe everything looks great and props are in order. Pull requests are designed to encourage and capture this type of conversation. So as a programmer, we've got to get out of this old school mindset that we're working by ourselves. Maybe if you're an indie developer, but in a corporate setting, in an enterprise setting, you're rarely ever working by yourself. You can also continue to push to your branch in light of discussion and feedback about your commits. If someone comments that you forgot to do something, or if there is a bug in the code, you can fix it in your branch and push up that change. GitHub will show your new commits and any additional feedback you may receive in the unified pull request view. All right, moving forward here, we have deployment. It says with GitHub, you can deploy from a branch for final testing in production before merging to master. Once your pull request has been reviewed and the branch passes your test, you can deploy your changes to verify them in production. If your branch causes issues, you can roll it back by deploying the existing master into production. Lastly, before we go back to GitHub and looking at a project, is merging. This is really the final step. Maybe it's before an alpha test or a beta test, is merging. Now that your changes have been verified in production, it is time to merge your code into the master branch. Once merged, pull requests preserve a record of the historical changes to your code because they're searchable. They let anyone go back in time to understand why and how a decision was made. So this is when you are satisfied that whatever you've done along the road here in your branch is ready to go mainstream to the rest of the team. Okay, let's go back over and take a look at the project management part. By the way, here's pull request. If anyone else has made a pull request, they show up right there. We have the projects tab. And the projects tab, I don't know if projects is quite the right word, at least in our little microcosm of our classroom, but don't think project is multiple Unity games that you're working on. Projects are where you identify specific tasks within your game development team. So let me just create a couple of them. Maybe I'll make one and I will refer to a team that's responsible for the main character, and I'll make that a team. I'm going to choose this layout here, and it will go through and make a to-do tab, an in progress, or a done team. By the way, they always give you these default suggestions here and examples. I always just say, hey, you know what, I don't need those. Archive all those. Yeah, give me a blank one. Okay, maybe I'll make another project besides the main character, and maybe it's going to be, I don't know, the enemy character or characters. And I'll say there's going to be a team of programmers that are responsible just for that. And again, this project management doesn't necessarily have to be about programming. It could be artwork too. So maybe there's an artwork team. So I can go in here and say, this is the team that's responsible for all the artwork and sprites. And put those there. Okay, so projects give us a space really to communicate as a team, maybe even if it's not face-to-face. At the very least, it lets everybody know what is going on within a specific team. So let me give you an example. I'll make a to-do here, and I'll say we need to draw main character sprite sheet. I believe that's probably 2 words there. And I can add it. Okay, so there's a to-do list. What's another one that I might want to do under this particular artwork? Maybe I want to do draw enemy character sprite sheet. Okay, and then maybe I want to draw platforms sprite sheet. Okay, so I'm just assigning all the tasks that I want this particular artwork sprites team to work on. Now this can be to where any teammate can add it, or you can actually make it to where only like a supervisor or the admin of this project is able to post these to-dos. Once we have work in progress, let's say for instance the artwork team says, hey, let's do work on the main character sprite sheet this week. They just drag and drop it over here, and now everybody in the project knows that the artwork sprite team is working. Maybe after they finish the main character sprite sheet, they go, okay, that's finished. I'll move that over there, and now they're ready to work on the enemy character. And what this bar here will indicate is purple means something is in progress, green means something has been completed, and the overall bar lets you know how close they are to finishing all of their current tasks. So that is really very helpful as far as being able to, as a team, especially with adolescents and teens working on teams, is to know what they need to do, what's been completed, and what maybe is in progress by other teammates. Because communication in school projects can sometimes be a real problem, as students don't communicate or assume that everybody knows what they're doing when they don't. One other thing I'm going to talk about before I wrap up this video, and that is automation. You can do this in any of your team projects, is to go to Manage Automation and make it to where things automatically show up in the to-do column. So I can say anytime a new issue is been made by anybody in the project, then it will automatically add it to this to the to-do list. So maybe one of the programmers says, hey, we need a sprite for a turtle in Mario. Let me go ahead and say that that's an issue. We don't have a turtle. And if they make that issue, it will automatically show up on the to-do page for the sprite team. So I'm going to say, yeah, update that. Okay, then, and I'll show you an example of it. I may have to do it in the next video if I run out of time here. Maybe I'm going to set the automation over here for in progress. If any issue gets reopened or re-examined, then it's going to show up under the in progress. And then lastly, something will show up in the done column automatically if an issue is closed out. When we come back in part 4, I will give you an example of putting in an issue or a pull request and showing you how it automatically shows up in these columns. So again, the project management part of GitHub itself is worth its weight in gold, at least in my mind. Even if you weren't even able to back up your files with push and pull, I think just for students working in a collaborative environment, this project management piece right here is really outstanding.